2, coordinate geometry of the circle, past paper question, June 2008, question 5. So here in part A, we're given that the centre of the circle is 3, 1, and it passes through the point P, which is 8, 3. So using x minus a squared plus y minus b squared equals r squared, we can find that x minus 3 squared plus y minus 1 squared equals r squared, because here we're told a equals 3 and b equals 1. And then substituting in the point we're given here, the point P, will give us 8 minus 3 squared plus 3 minus 1 squared, and that will equal r squared, because this point lies on the edge of the circle. So 8 minus 3 gives me 5, 5 squared gives me 25, plus 3 minus 1 gives me 2, 2 squared gives me 4, and that will be equal to r squared. So that gives us the equation of the circle x minus 3 squared plus y minus 1 squared equals 25 plus 4, which is 29. So again, our final answer for part A was x minus 3 squared plus y minus 1 squared equals 29. Moving on to part B, find an equation for the tangent to C at P, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So we need to find the gradient of the radius of the circle at the point 8, 3, which is this point P. So that means that we need to do m, which is equal to y2 minus y1 over x2 minus x1. Substituting in the point that we found for the centre, which was 3, 1, and the point that we're given P, this gives us 3 minus 1 divided by 8 minus 3, which gives us 2/5. So that's the gradient of the radius. Now the tangent to the circle will be perpendicular to this line. So that means that we need to do m1 times m2 equals minus 1. Well, we know that m1 is equal to 2/5, so 2/5 times m2 equals minus 1, which gives us m2 is equal to minus 5 over 2. So substituting this into the equation y minus y1 equals m, x minus x1 will give us y minus, well, we've got the point P, which is 8, 3, so 3 equals minus 5 over 2, x minus 8. So times in the whole thing through by the 2 gives us 2y minus 6 equals minus 5 lots of x minus 8. Expanding out this bracket gives me 2y minus 6 equals 40 minus 5x. And then moving everything over to the other side to get it into the form that we're asked for in the question gives me 5 x plus 2y minus 46 equals 0. So that is the equation of the tangent to the circle at the point P.